So here we're going to find limits of trigonometric functions, and there's one theorem that you cannot forget, and you have to understand very clearly how this works. So it's limit as x approaches 0, sine x over x. If you actually plug it in, you get 0 over 0. But we prove using the squeezing theorem that it's equal to 1, and you're allowed to use this rule. So what does this mean? Limit as x approaches 0, sine 25x. What would we need in the denominator to make it a 1? We need a 25x to make it a 1. Whatever angle you see here, you need to see the exact same number in the denominator. And that's the only way we can make it a 1. Some things that you cannot do, I just want to just make sure you understand this and just remind you what you're not allowed to do. It almost feels like it's... Can you cancel anything that sits inside the sine function with anything outside? This is completely wrong. You do not touch the angle. I always tell you that in class. This is the number to which the sine function is applied, and it changes everything completely when you apply the sine function. It cancels with nothing outside. For example, the x's do not cancel, the 25s do not cancel. There's another error. Suppose you have sine 2x. Can you go sine 2 times x and separate this from this? The answer is no. These two go together. This is the number to which you're applying the sine function. So you cannot separate them like that. Okay. So anything, you cannot touch the angle inside the sine function. So if you're applying the sine function to a number, do not touch the number. You cannot mess with it. Anything outside you can manipulate. So let's look at this. So we have limit sine 3x divided by sine 4x as x approaches 0. So the only theorem we know is this, when x approaches 0. So we want to use this theorem. So what we do is we go limit as x approaches 0, sine 3x divided by, and what is it that we would want here in order to make it a 1 as x approaches 0? Whatever the angle here is, copy that number and write it here. You multiply and divide by the exact same number, so you're not changing the function. Another thing I'd like to tell you is when you multiply and divide by the number, don't put your number here, because that might appear as if you're multiplying it to the angle. So just to be absolutely clear, write it on the left side. Okay. Now divided by, we're looking at sine 4x and thinking, what would we like to see here in the denominator? So it would approach 1 as x approached 0. Whatever the angle is, this is the angle to which you're applying the sine function. Write down the exact same number. Multiply and divide by the same number. So now we're ready to apply the theorem, but if you plug in the 0, you're still going to get a 0 over 0 because the x in the numerator and the x in the denominator becomes 0. So you want to cancel those first. And now when you apply the theorem, this quantity approaches 0 as the limit x approaches 0. This quantity approaches 1 as the limit approaches 0. This quantity approaches 1 as the limit x approaches 0. What are we left with? The 3 in the numerator and the 4 in the denominator. And until you actually apply the limit, keep writing limit as x approaches 0. Okay. So basically what we've done is 3 over 4 limit is applied to sine 3x over 3x, and same thing in the denominator, limit as x approaches 0 is applied to sine 4x over 4x, and that's how we get a 1. Now real quick, this is an easier one, but let me just show you how this is done. Limit as x approaches 0. Sine squared x is just another way of writing sine x times sine x. But remember, we have only one x in the denominator. If it were an x squared, we would write it as x times x, and each one of the signs would get an x. But here, unfortunately, we just have one x, and the other sign just gets a 1. So now when we apply limits, remember, you have to keep writing limits until you have actually applied the limits. So this approaches 1. When we apply the limit to sine x as x approaches 0, the only thing we can do is substitute the x equals 0. So you get sine 0, which is equal to 1.